Arrange this isoelectronic series in order of increasing radius. Again, remember what isoelectronic means. Isoelectronic means same electron configuration. Things to remember here are general trends. General trend is size decreases that way and decreases going up to down. So size increases this direction, generally speaking, in neutral species. But also cations are smaller than neutral species. You've lost one of the electrons. You have more protons now than it's used to pulling on the remaining electrons. So it's going to make it smaller. And anions are larger than the neutral species. An anion means I've added electrons, so now I have more electrons holding this together. More electrons being held together by the same number of protons, it's going to hold them a little bit less tightly. So, magnesium has the smallest charge, most protons holding it together, by sodium ion, fluoride ion, and O2 minus. So oxide will be the largest because it's got the most number of electrons with that number of protons. Magnesium the smallest, lots of protons, pulling on a much smaller number of electrons. Arrange these elements in order of decreasing atomic radius. So that means largest to smallest. Its atomic radius, remember, it gets larger as I go this way and larger down. Fluorine is really tiny. Helium's even smaller. Francium is very large. So, cesium, its last electron is in 6s1. Antimony, its last electron is 5p3. Sulfur, its last electron is 3p4. Lead, its last electron is 6p2. And selenium, its last electron is 4p4. So just thinking about that, what does that mean? Well, that means that cesium and lead have to be the biggest guys. Okay, they're going to be the largest because they have these n equals 6 energy level. But if I think about there on the table, cesium's over here, lead's over here, so cesium's going to be bigger than lead. Next up, I've got antimony in my 5th energy level. Next up, I've got selenium in my 4th energy level. And lastly, I've got sulfur in the 3rd energy level. Which is the larger of each pairing? Aluminum or indium? Well, I think about where the last electron was added in. So 3s1 or 5p1. Definitely the indium. Silicon is 3s2. Nitrogen is 2p3. Silicon, because again, that number in front, the number here is your energy level. And the higher that number is, the further it is from the nucleus. Phosphorus is 3p3. Lead, 6p2. Lead, higher energy level. Carbon is 2s2. And fluorine is 2p5. Sorry, carbon is 2p2. And fluorine is 2p5. Carbon, because this is the trend of going across the table, getting smaller. They're in the same energy level, so now I have to think about effective nuclear charge, and the effective nuclear charge of fluorine will be higher because it has more protons pulling, yes, on more electrons, but more protons in that nucleus, in that centralized positively charged area. And our last example, which is the larger species in each pairing? Strontium or strontium ion? Strontium. Cations, always smaller. than their neutral atom. Nitrogen or nitride? Nitride. Anions, always larger than their neutral atom. Nickel or nickel 2 plus, nickel, and then S2 minus or calcium. If I look at these, they're isoelectronic. The S2 minus would be larger because it has less protons pulling on the same number of electrons. Calcium has more protons pulling on the same number of